I was asking you, what are the postulates that are supposed to be read in order to know the basic things about the quantum mechanics? So if you see the quantum mechanics, the first unit it talks about uh, quantum mechanics and its application, where we are supposed to study about the time-dependent Schrodinger equations, right? So see now,
Yeah.
this one is like, it is a quantum mechanics. I hope you can see it, right?
Yes, sir.
Quantum mechanics. So I was asking you,
Mm.
what are the postulates? Postulates means I can say that first one. Let me put it as postulates of quantum mechanics. So there will be if you want to study about the quantum mechanics, first you should be aware about this postulates only. That once if you know the postulate, then only we can enter into the next topic. Without that one, I cannot assure you to what extent you have studied there.
Sir, postulate, like what I mean from postulates of quantum mechanics, that how it is applicable and to which it is applicable. You mean that?
Have you understood what is the meaning of postulate?
Yes, sir. Like previous assumption over quantum mechanics.
It is something like it is a suggestions or assumptions that are supposed to be made in order to think about the existence of the quantum mechanics, right?
Yes, sir.
Postulate means we are talking about the fact or the truth of this quantum mechanics regarding on basis of something like the reasoning of that one, or else discussion or belief of how this particular assumptions are happening and how this particular existence of the particles takes place.
Yes, sir. I know this, sir. Sir, the assumption over quantum mechanics is that first it is applicable over very that kind of particle which are very small, and their
Uh,
speed is relative to speed of light.
okay, still,
Over, yeah, and these are these particle have duality, which is wave and particle nature both present in them.
it is present in both the wave and particle, right? See,
Yeah, yeah, sir.
first let me put this one so that I'll get some clarity about what extent you have studied. The first one, the first postulate is that it is a wave function uh, postulate. Okay, wave function postulate. So, see, you have told me that you have studied about this one, right? Can you tell me what is this
Mm.
wave function postulate?
Sir, it is represented by psi, and as I said, it should obey the three principles, which is it
Okay,
should be finite,
fine.
square integrable, yeah,
Okay,
and continuous.
fine. Then how it is this one in the quantum mechanics? This one could be one of the important question for you. Why? Because I have gone through some of the previous question papers where which are related to the BSc physics honors. They were mostly many
But,
times they
sir,
were yeah.
sir, your voice is too um, high. Can you lower it?
Seen some of the previous question papers where this question was been
No, no,
asked
sir. Sir, your voice is so high.
so high.
Yeah,
Yeah. See and now is it okay now?
it is same.
I'm talking normally.
Sir, I have reduced my.
Yeah, you can just put your headset just far to your ear. Okay, I'm
Okay.
talking normally to you. Fine. See now. This question was asked many times in the previous question papers. So that's the reason I have asked you what are the postulates of the of quantum mechanics. So see now, first one, listen here. Now. The wave function postulate. What does this wave function postulate? It tells about the state of a quantum mechanical system. Quantum mechanical system is completely specified. This is most important. Is completely specified completely by a function called as by a function called, what is this one symbol? I hope you have studied
Phi.
about it. Huh?
Phi. Phi.
Phi, right? Function called phi of r
Phi.
comma t. Yeah, psi.
Hmm.
That that depends on that depends upon what? It depends upon the coordinate systems. That means depends on the coordinates of a particle. It can be of a particle or it can be of different kinds of particles in the quantums, different quantums, particles, and also it depends upon the time. This is the first one. Is it the one which you have studied?
Yes, sir.
This is the first wave function postulate. If the quantum mechanics mechanical system has to completely establish, means what it has to work it out, means the first postulate is that assumption is that the system of a quantum mechanical um, a quantum mechanical system is completely specified by a function called a psi of r comma t. This particular function has to depend upon two main important what is this points. That first one is a particle and it has to depend upon the time also.
Hmm.
Okay, that's the first
Yes,
postulate.
sir.
Why? Because
Hmm.
this question has been asked many times. That's why I'm just trying to recollect all the things. There. Okay, the second one, CNO. If you go to the second postulate, yeah, can you please tell me the postulate number two?
Sir, actually, sir, I didn't study it like postulate, like whatever I answered you. I
Yeah,
studied
yeah.
it like my
Why?
teacher
Because
taught me.
in order to enter into the quantum mechanics, we should know the postulates first.
Okay.
Okay, Seema. The next one is a experimental observations. You might have studied about the observations, right? Experimental observe observations, or we can call observables, whatever we have observed with the help of the experiments. This is second postulate. It means what does it mean in the experimental observables? It means that for every observable in a classical mechanics, where it will be that particular observable will be corresponding to either linear or Hermitian operator in the quantum mechanics. I hope you have heard about the Hermitian operator,
Yes, sir. Permission. Yes, sir.
right? So see now. So the second postulate is that for for every observable, for every observable uh, which is in a classical mechanics, 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 and that has to correspond to linear, and also it has to correspond to what? Hermitian.
Hmm.
Hermitian operator in your quantum mechanics. Is it okay?
Yes, sir.
Okay, fine. The third one. Are you noting down or just you're just looking into this one?
No, sir, I'm looking. Sir, you will
Yes.
provide this PPT.
Okay, fine, fine. The third one is the third kind of postulate which we are supposed to study about the quantum mechanics is that the third one is the individual measurements. It is the individual measurements. What do you mean by individual measurements? Here the term individual measurements means if you are doing any kind of measurements, or else let me put it in this way, in any of the measurements of the observable which is to be observed, which has to undergo any kind of experiment. So now in any of the measurement of the observable associated with the operator A cap, that the only values that will ever be observed are the eigenvalues. Why it has to be eigenvalues? Because it has to satisfy one equation. That equation is called as an eigenvalue equation. That's the main reason. The third postulate is all about the individual measurements. It is all about the measuring of the observable. So see now. In any measurements, sorry, of the observable, what will happen? Uh, this observable is associated with I can say with an operator. As I have told the operator name is A and A cap. Okay, fine. Then what will happen? Then the only value we can say that the only value when we are doing some measurements is not the value, it's the values. The only values that will be observed, are the eigenvalues. Eigenvalues, and we can say that these values and observables satisfy the eigenvalue equation. This is what is called as the third what is that postulate of the quantum mechanics. Means if you're doing any kind of in order to understand about the quantum mechanics or assumptions, in order to make some assumptions or in order to make some observations, we need one observable, any of the parameter which is to be observed. That parameter will be doing an individual measurement. So in any of the individual measurement of the observable, that observable first has to be associated with an operator. The operator, let the operator be equal to A cap. Then the only value which is observed related to that parameter, that can be only eigenvalues only. Means a parameter, the observable is associated with the eigenvalues only. And these values of the observable has to satisfy the eigenvalue equation. That's the third postulate of the quantum mechanics. Have you studied this one?
Yes, sir, I had studied, but not in like statement form.
Okay, fine. Why? Because see, they'll be asking you the question regarding the postulate of quantum mechanics, and you are supposed to
Sure.
detail that one. I hope you understand what is the standard of the BSc Physics Honors.
Yes, sir.
If you simply write like
Sir,
this, you are not going to get the, they'll not be awarding you the marks.
yes, sir.
Okay, the fourth one, Manu. Now the fourth postulate. Okay. The fourth postulate is regarding what will be the expectation of the values which you are just now tried about measurements. What are the expectation of the values, and how is there any chance of collapsing of the wave function? We have seen the wave function in the first postulate, right? Is there
Mm.
any collapsing of the wave function? That is about the fourth postulate. Fourth postulate is what? Expectation values and it about the collapse of the wave function.
What is expectation value?
Sorry. Expectation value means, see, listen here now. If there is any system, if there is any
Mm.
system and this system is in a state, like I can say that if I'm having a system that is in a state which is described by normalized wave function is
Mm.
psi, right? Then the average value of this observable which is correspondent to one of the parameter I have taken a cap. The average value of this observable correspondent to a function has to be given.
Okay.
It has to be given directly. So that is about the fourth postulate. Okay. So see now. Let me
Yes.
let me say like it. Let me write like this. See, ma'am, I'm just trying to give you the postulates of the quantum mechanics in a brief. Why? Because I have seen it is not been asked for the long answer question. It is asked for some minimum marks. If you write this much, it's more than enough. If you want, I'll try to elaborate in the next class about all each and every postulate. Okay.
Okay.
If a system is in a state what I told in a state that is described by a normalized wave function. Normalized wave function psi. Okay. Normalized wave function psi. Then what will happen? The average value. We need to find out the values. So we were trying to find out the values there. So what will be the average value of this one? The average value of this observable, whatever the observable you have found out, it's not like we are finding only one values. If you are doing some experiments on one observable, you're trying to find out some different ways of experiments upon that observable, and you'll be getting the different values. You cannot just conclude your experiment with one value. Ultimately, after getting some values which are nearby, what you'll be doing, you'll be finding out the average of that one. Then the average of that average value of that observable, which is corresponding to what is that our corresponding to what I have taken there, corresponding to operator. What is the operator we have taken? A cap. So
Yes.
corresponding to
Mm.
the operator A cap, okay, A cap. This one, in order to find out that average value, it has been given by some formula. That is most important one. See now. A is equal to integration of minus infinity to infinity psi star. I'll tell about this one. Then again A cap psi d phi dt. This is the equation in order to find out your what is that average value. So see now. We can I'll just try to just put it out instead of writing everything. I'll just tell you here the measurement of this what are the psi I have written yields from what? A eigenvalue. Either that will yield from an eigenvalue. Let the eigenvalue equal to small a I, small a suffix I. The value of this
Mm.
measurement of psi, the measurement of this psi comes from an eigenvalue. That let that eigenvalue equal to a suffix small I.
Yeah. Mm.
Okay.
Mm.
Now the wave function, whenever I can say like that. Let me put it in the other way so that it will be easy for you to understand. After like I can say, an important consequence of this fourth postulate is that here in this fourth postulate, what will happen after doing the measurement of this psi, we'll be getting some eigenvalue a small I. Is it okay? Why we are going
Mm.
to the for this psi? After doing the measurement of this psi, that measurement will yield us some eigenvalue. Let the eigenvalue is equal to a small I. The wave function, whenever it comes this eigenvalue a small I, then the wave function immediately collapses into corresponding what is that eigenstate, corresponding eigenstate. That eigenstate can be called as psi of I. Is it okay, ma? What you're doing here, you're doing some measurement of the observable. Once the
Mm.
measurement of this observable, which is done with respect to the wave function psi, you will be getting some the output of that one will be a suffix I, or this measurement of psi will yield us some a suffix small I. And once this a suffix small I has been obtained, the wave function will collapse into the eigenstate wave function, that is psi of I.
Mm.
Okay, or else I'll put it in the other way. We can also say in this way that if I want to talk in the other words, the measurement which affects the state, this is a measurement which will affect the state of the system. Is it right or not?
Yes, sir.
Because your wave function is psi. Actually, that psi is what? The psi is a normalized wave function.
Mm.
It's a normalized wave functions. When you're doing some measurement upon this psi, what is happening? That is yielding us some output. The output is equal to a suffix small I. Once this a suffix small I is obtained, we are going to find out that the normalized wave function psi is getting collapsed into the eigenstate wave function that is called as a psi of I.
Mm.
So
Yes,
ultimately,
sir,
what we
got
can
it.
say, yeah, ultimately we can say that the measurement, this kind of measurement will affect the state of the system. This implies
Yes, sir.
the measurements will affect the state of system. This kind of measurements will affect the state of system. And this kind of facts is used in many experimental tests which are applicable to the quantum mechanics.
Yes, sir.
Okay. This kind
Mm.
of experiments are applicable to what is that any kind of experiments which are done related to the quantum mechanics. One you might have heard about one experimental test. I'm just writing over here where these are applicable. Is that we can see that you might have studied also Stern Gerlach test. I heard about this one. It's a Stern
Yes, sir.
Gerlach
Yes.
test, Gerlach experiment, which is done in the quantum mechanics.
Mm.
Is it okay, ma? Is it clear up to here now?
Yes, sir.
So this is about um, the fourth postulate. Shall I move ahead for the next one?
Yes, sir.
I hope you're finding it easy, right?
Yes, sir.
The fifth postulate now. The postulate. What is the fifth postulate? It's a postulate regarding the time evolution. What is that we can call evolution? It's a postulate regarding the time evolution. So what do you mean by time evolution here? In this time evolution postulate, what we understand is that the wave function which we have already defined as a psi, that wave function of a system evolves in terms of the time, according to the time dependent Schrodinger equation. This is the fifth postulate. We are studying this postulate. Why? In order to understand what is the quantum mechanics and how it is related with the Schrodinger equation. So see now, what is the fifth one? The wave function the wave function, we can say psi, I think I have taken it, of a system, wave function of a system evolves in evolves
Yes, sir.
in time, which is according to, which is like according to time dependent, time dependent, what is that, Schrodinger equation.
Excuse me, sir.
Yeah, just a minute now. Schrodinger equation. Yeah, please tell me.
Yes, sir. Sir, I have a confusion. Whatever I read about quantum mechanics, from there I have a confusion. Sir, uh, do we study quantum mechanics like in my course? Do we study about the limited wave function? Like I studied that in quantum mechanics we have normal wave which is extended up to infinity, minus infinity to plus infinity. But here we have wave packets, so we
Hmm,
have limited range. So
hmm.
why, if we study like that, why do we study like that?
Actually, I didn't get your question. Just a minute. I'll complete this one and I'll come to you. Okay? I'll complete
Okay.
this six uh, postulates and come back to you. I hope you might have studied about the Schrodinger equation. I'm writing the Schrodinger equation over here. This is about the
Mm.
fifth one now. The wave function psi of a system evolves in the time according to the time-dependent Schrodinger equation. This is about the fifth one. That's why we are talking about how the what is that, time-dependent Schrodinger equations. That is your first concept about uh, yeah, in this particular quantum mechanics topics. And now, if I want to go to the next one, sixth one, the sixth postulate of this quantum mechanics is that you're supposed to understand the Pauli's exclusion principle. Pauli's exclusion principle. It's all about the Pauli's exclusion principle. So, CNO. What does its Pauli's exclusion principle tells about? It talks about that the total the total wave function of a system, the total wave function of a system with some n spin, some there are n spin, we can say n spin, let that n spin is equal to 12 particles. 12 particles. What does it mean? You have studied about this in the Pauli's exclusion principle, that regarding the spinning, which is also called as, these particles are also called as fermions. I hope you might have heard about these
Yes.
terms, fermions. That these particles must be, first of all, it has to be an anti-symmetric. It has to be anti-symmetric in nature. It has to be an anti-symmetric in nature. That is with respect to what? The interchange of all the coordinates. With respect to interchange of coordinates of one particle with other particle. This is about your uh, what is that, sixth one. So we can say that we can also say that in this way. This fermions we can write also like this. It can be written as n spin minus 1 by 2 particle, which can be written as n spin minus 1 by 2 particles, which is called as these particles are called as fermions. It has to be 1 by 2 particles, which is called as a fermions. Now, see now, if I'm having spin minus one particle, if I'm talking about the spin minus one particle, I hope you might have studied about this polish. Let me say, for spin minus one particle, spin minus one particle means what? The spin minus one particle is also called as bosons. Have you heard about this one?
Yes, sir. Yes, sir.
Right? For this bosons, like if you take for like any kind of bosons, again we need to write some what is that wave function equations, and that wave function equation will be like symmetric equation. For fermions, the equation will be different. For wave function, it will be different. Do you know that equation? Like if we say that if the particles, if I write psi of r1 comma r2 comma r3 so on up to rn is equal to minus psi of r2 comma r1 comma so on up to rn. That is, this is for what? Fermion. Fermion is what? N spin minus half particle. N spin minus half particles. Now, if I write the same equation like psi of r1 comma r2 comma so on up to rn, that is equal to plus of r2 comma r1 so on up to rn. This can be written equation for the bosons. I hope you have read about these equations. So this is a this lecture was regarding the learning about different kinds of postulates of the quantum mechanics.
Hmm.
Quantum mechanics. If you have got any doubts, you can just talk to me regarding this quantum postulates, and later we'll discuss about this one.
Sir, I don't have doubt in this. Sir, I want to ask